Good day, dear students. For today's lesson, let me discuss to you the topic all about percentiles and t-distribution. So what are percentiles? Okay, this concept has already been discussed to you during your junior high school math subject. So in this case, let's define percentiles as the identifier of students' performance in comparison to the performance of the whole class. For example, your score is at the 90th percentile. It only means that there were 90% of your class having low scores than yours. Or you are better, your score is better than the 90% of the class. And that there were 10% of the class having higher scores than your score. So that is how we interpret percentile. T-distribution. It is also known as students' T-distribution. It is just a family of distributions that look almost identical or the same to the normal distribution curve or the Z. Okay, talk about the Z, only a bit shorter and stouter. So for you to visualize, here is an image, okay, differentiating the two curves. So the curve in red color, that is a standard normal curve. So that's that one. And then the curve in the blue color is the curve of a t-distribution. As you can observe, the curve of t-distribution is a bit shorter and it is a little bit fatter or stouter. Okay, it's a little bit fat. So that is the difference between the two curves. Okay. Next, it is used instead of the normal distribution when you have small samples. If your sample are small, then the best to use is t-distribution for us to obtain accurate and precise results. And then the larger the sample size, the more the distribution, the t-distribution looks like the normal distribution. For example, if the number of population is 10 and the sample size n is 9, then in that case, the curve would look like the same with the normal distribution. Okay. Let's now talk about the properties of t-distribution. Just like with the normal distribution, it has also smooth shape and is symmetric. It has also a mean of 0 that is located at the center of the curve. And that, unlike the normal curve, t-distribution does not assume that the population standard deviation is known. There is no assumption, okay, at all. Because t-distribution wants the accuracy and the precision of results. So it is defined by the degrees of freedom, which is related to the sample size, which we'll be talking about later after this slide. So most useful for small sample sizes when the population standard deviation is not known or both. So as the sample size increases, then the t-distribution becomes more similar to a normal distribution as what I have talked about a while ago. Here we have a t-distribution table. So this is the values here talks about the areas on the right tail of the curve. On the first column, we have here the degrees of freedom. Okay, this is related to the sample size. And then here, the number above on the first row is the critical values or the areas. Okay, and here, the numbers here are the t values. Okay. Now let's have some example. So identify the t-value whose number of samples n equals 7 and has an area A, alpha equals 0.05. So how to solve that? So the first step is to identify the degrees of freedom or df using this formula. df is equal to n minus 1. Then substitute the given values. So that is 7 minus 1, that is equal to 6. Therefore, the degrees of freedom is equal to 6. Next step is to locate the t-value on the t-table using the degrees of freedom and the area alpha. So how are we going to do that? Okay, just the same as what we did on the z-table. You have to locate the degrees of freedom and then the critical value or the area, and then on the center, on the intersection, that is now the t-value. So therefore, the t-value for n equals 7 and area alpha of 0.05 is 1.943180. So this is how we identify t-value. Okay, next example. Next example, we have here Find the t-value's degrees of freedom is 20 and has an area alpha of 0.01. So to solve that, since the degrees of freedom and the area are already given, then we just have to locate the t-value on the table only. Okay, so just the same process, locate the degrees of freedom and then the critical value or area. Then at their intersection, there you go, the t-value. So therefore, the t-value is 2.52798. Okay, next scenario. So next example, identify the t-value for the 95th percentile given that the number of samples n equals 30. So, step number 1, we have here. So, the 95th percentile, guys, is the number where 95% of the values lie below it and 5% lie above it. It means that the right tail area will be equal to 0.05. Okay, this is the remaining area on the tail end since we talk about t values. Okay, 0.05. Okay, that is 5% to be exact. Then, we have to find the degrees of freedom. We have to use a formula, df is equal to n minus 1. Then, substitute the given value. So, that is n equals 30. Then, 30 minus 1. Therefore, degrees of freedom equals 29. So, by using the t-table, have to locate the t-value. So, the degrees of freedom is 29. And the right tail area is 0.05. Then, their intersection, that would be our t-value. Therefore, the t-value is equal to 1.699127. So that is how we are going to locate the t-value in this kind of scenario. Okay, next. Now let's talk about the length of confidence interval and appropriate sample size. Okay, let's first define the following terminologies. Confidence interval, it only refers to the probability that a population parameter. Take note, population parameter are just descriptive measure that will estimate the value of some statistical measure of a population like population mean, population standard deviation, and population variance. Okay, that will fall between a set of values for a certain proportion of time. So confidence intervals measure the degree of uncertainty or certainty in a sampling method. So how sure we are. Okay, so they can take any number of probability limits with the most common being a 95% or 99% confidence interval. So these are the most commonly used confidence interval. So the next terminology is narrowness of the interval. So this pertains to a small width in relation to the length of the confidence interval. Okay, kung gaano kaliit yung value ng ating interval, yung length natin. Next. So length of confidence interval refers to the absolute difference between the upper confidence limit and the lower confidence limit. Only the absolute difference. So here is the formula. So LCI is equal to the absolute value of UCL minus LCL or the absolute value of LCL minus UCL. Okay, so here guys, we have the absolute value. So if your answer here, if the difference is negative, then with the absolute value that will be equal to positive. That will be positive. Even if the result is negative, then the final answer would be positive when we talk about absolute value. But instead using this formula, we're gonna have to use this one. LCI is equal to UCL minus LCI. Okay, we're in LCI is the length of confidence interval, UCL is the upper confidence limit, LCL is the lower confidence limit. Okay, now let's have some example. Example number 1. So find the length of the confidence interval where the probability falls between 0.275 and 0.360. First step is to determine the given. We have the upper, which has the higher value, 0.360. The lower limit, that is the value with the lesser value, 2.275. Then use the formula. Subtract lang natin yan. So 0.360 minus 0.275. Therefore, the length of confidence is 0.085. Okay, always remember that we have to write first the larger value, followed by the lower value. Next. Find the length of the confidence interval given the following. Upper confidence limit 0.805, lower confidence limit equals 0.526. Okay, using the formula, okay, write first the upper confidence limit, that is 0.805, minus the lower confidence limit, which is equal to 0.526. By subtraction, we have the length of confidence interval is equal to 0.279. Okay. Now, we have here the formula for interval estimate of population mean with known variance, if the variance is known or is given. So this one, we have here the formula. So the mean, x bar is the sample mean. So sample mean minus z sub a over 2 times standard deviation over the square root of n. Sa kabila naman is mean plus z sub a over 2 times standard deviation divided by square root of n. So on the left side, this is the value for the lower confidence limit. And then here on the right side is the value for the upper confidence limit. And then here we have the formula to find the length of the confidence interval. Okay, for us to find, we're not going to subtract the 2, but instead we have to use the formula 2 times z sub a over 2 times standard deviation all over square root of n, wherein z sub a over 2 is the z value. We have the letter a, but that must be a Greek letter alpha. Okay, we have this one. This is a sigma, lowercase sigma. It denotes standard deviation of a population. And then we also have your small letter n. It denotes the sample size. Then let's now have some example. Example number 3. Find the length of the confidence interval given the following data. Standard deviation is equal to 0.3, sample size equals 70, confidence level is 95%. So first step is to write down the given, okay? Then, let's first determine the confidence coefficient. So that is A over 2, alpha over 2. So the first step is to use this equation. Quantity 1 minus A times 100% equals the given confidence level, which is 95%. Okay, always follow this format. And then after that, by multiplying 100% to 1 minus A, that is only equal to 1 minus A equals 95%. Then we converted 95% to its decimal form, that is equal to 0.95. Okay, and then by using subtraction property of equality, we have to subtract 1 on both sides. So minus 1, then minus 1. So 1 minus 1, that is 0. So we have the remaining negative A. Then 0.95 minus 1, that is equal to negative 0.05. Then for us to eliminate the negative sign here on the alpha, we have to multiply both sides with negative 1 to eliminate the negative sign. So that is negative 1 times negative A equals A. The negative 0.05 times negative 1, that is only equal to 0.05. And then dividing the both sides by 2, we have here 0.05 divided by 2, that is equal to 0.025. This is now the confidence coefficient, 0.025. This is the area on the very tail, the right tail of the curve. Okay, and for us to identify where would be the point, okay, the starting point for that, we have to do the following. So, we have to subtract 0.25 from 0.500. Why? Because the right tail of the curve, we're dealing with the right half of the curve. Okay? So we have to subtract that. So 0.500 minus 0.025, that is equal to 0.475. This is now the area, okay? The area from that point going to the mean. Okay, ito yung kailangan excluded natin. And for us to determine what is the z value of this area, we have to use the z table. So we have here, we have to find here on the values. So we have your 0.4750. So that is 1.96. Therefore, z sub a over 2 is equal to 1.96. So because from this point going to the right, there lies this area which is equal to 0.025. So that is the explanation. Okay, next. So next, we have to do the following. Substitute the values in the formula and compute. So this is now the formula for the length of confidence interval. Then substitute the given. So 2 times this one, that is the z-value, which is 1.96, times the standard deviation, which is 0.3, and the sample size is equal to 70. Okay, so by multiplying 2 times 1.96 times 0.3, that is equal to 1.176. And then we have to divide 1.176 by the square root of 70. It must be 70. And the result is 0.1406. And this is now the length of confidence interval. Okay, next. So the formula, now let's talk about the formula for confidence interval of a population mean if the sample size is less than 30 and is less than 30. So this case, we are talking about the t values. This is now the formula. So sample mean minus t sub a over 2 times standard deviation all over square root of n. This is now the lower confidence limit. And this one on the right side is the upper confidence limit. So it must be plus. Okay? So this one here must be plus. Okay, plus. Okay, it talks about the upper confidence limit. So the formula to find the length of the confidence interval is equal to 2t sub a over 2 times standard deviation all over n, wherein t sub a over 2 is the t value. Okay, let's have some example. Example number 4. So find the length of the confidence interval given the following data. We have standard deviation 6.5, sample size equals 15, confidence level is 99%. So write down the given, and then the next step is to find the degrees of freedom. Using the formula, df is equal to n minus 1. Then substitute the given. So n equals 15, then 15 minus 1. Therefore, the degrees of freedom is equal to 14. Then next step is to find the confidence coefficient using this formula, the steps. So we have quantity 1 minus a times 100% equals the given confidence level, which is 99%. And 100% of 1 minus a is also 1 minus a. Then convert natin ang 99% to its decimal value, which is 0.99. Then by having subtraction property of equality, subtract lang tayo ng 1 both sides. So 1 minus 1, 0. 0.99 minus 1, ayun, we have negative 0.01. So this will be the next step. So then we have negative a equals negative 0.01. So to eliminate the negative sign, we have to multiply both sides of the equations by negative 1. So by multiplication, we have a equals 0.01. So we have to divide both sides by 2. And 0.01 divided by 2 is equal to 0.005. So this value is the critical area. Okay. And then using this value, we have to find the t value. So given the degrees of freedom 14 and the area alpha over 2 is 0.005, then the t value is equal to 2.977. Okay? Next. We then substitute the values we already determined a while ago. Okay? So we have your 2 times the t value, which is 2.977, multiply 2, the standard deviation 6.5 divided by square root of 15, the sample size. Okay, by multiplication, 2 times 2.977 times 6.5, that is equal to 38.701. And then, divide lang natin si 38.701 by square root of 15 using your scientific calculator or your calculators in your phones. So by division, we have the length of confidence interval equals to 9.99. Okay. Now let's proceed on how to derive the formula for a sample size. So in deriving the formula for sample size, there are two things to remember. That is confidence and the narrowness of the interval. So confidence interval only describes the uncertainty inherent in this estimate and describes a range of values within which we can be reasonably sure that true effect actually lies within that interval. So the narrowness of the interval pertains to a small width in relation to the length of the confidence interval. Okay. So if the confidence interval is relatively narrow, masyado siyang maiksi. From 0.70 to the 0.80, that is only 0.10. That is the interval. So the effect size is known precisely. If the interval is wider, for example, from 0.60 to 0.93, that is 0.33. That is the interval. So the uncertainty is greater, that we are not sure. So although there may still be enough precision to make decisions about the utility of the intervention. So intervals that are very wide, so indicate that we have little knowledge about the effect. Kapag masyadong wide. Okay, mas malaki yung length of interval natin. And that further information is needed. So the computing formula in determining sample size is derived from the formula of the margin of error E, wherein it is the formula. E is equal to Z sub A over 2 times standard deviation all over the square root of N. So we have to study the derivation of the computing formula for determining minimum sample size when estimating a population mean. So this time we're gonna have to estimate the population mean. So we have to discuss the elements of the formula on the next slide. So to solve for n, which is a sample size needed in estimating a population mean, do the following steps. So this is now the formula for the margin error. We have to multiply both sides with square root of n to eliminate the denominator on the right side of the equation. So by multiplication, we have square root of n times E equals Z sub A over 2 times the standard deviation. And this time, we have to divide both sides with E, okay, to isolate the sample size n. So we have here, square root of n is equal to Z sub A over 2 times standard deviation divided by E. And now, for us to eliminate the radical sign on the left side of the equation, we have to square both sides. So by squaring both sides, on the left side, it will be equal to n only. Then equals square of Z sub A over 2 times standard deviation all over E. So this is now the formula for us to compute what would be the minimum sample size in estimating population mean. So let's have some example. Okay? Again, this is the formula wherein Z sub A over 2 is the Z value. Lowercase sigma is the standard deviation. Small letter n is the number of sample. Capital letter E is the margin of error. Okay. Now, example. In a certain barangay, Mario wants to estimate the mean weight in kilograms of all 7-year-old children to be included in a feeding program. He wants to be 99% confident that the estimate of the population mean is accurate to within 0.06 kilograms. Suppose from a previous study, the standard deviation of the weights of the target population was 0.5 kilograms. So what should the sample size be? So note further that the phrase accurate to within 0.06 kilograms indicates a narrowed width. Masyado siyang maiksi of the confidence interval. Thus, the desired error E is equal to 0.06. Ito yung deciding error natin. The error. Okay, so the population standard deviation is 0.5 kilograms as indicated on the problem. So first step is to write the given. We have here 99% confidence. Margin of error E equals 0.06 kilograms. Standard deviation is 0.5 kilograms. Okay. Now, the next step is to do the following. We have your alpha is equal to 100% minus the given confidence level, which is 99%. Okay. So we only have here 1. Convert lang natin sila into decimal form. So A is equal to 1 minus 0.99. By subtraction, that is equal to 0.01. Okay, dividing both sides by 2. We have here 0.01 divided by 2. Therefore, A or alpha over 2 is equal to 0.005. Okay, this is just the same given on the previous example. So using this critical value, we have to locate we must first subtract this value on from 0.500. So 0.500 minus 0.005, that is equal to 0.495. So by using the z table, we have to locate this area and find what would be its corresponding z value, and that is equal to 1.96. This is now the z value. Then proceed na tayo on the next step. Okay, the next step is to use this formula and substitute the values we have a while ago. So z sub a over 2, that is the z value, which is 1.96. The standard deviation is 0.5. The margin of error is 0.06. Okay, multiply lang natin. 1.96 times 0.5, that is equal to 0.92. Then divide natin, 0.92 divided by 0.06, that is equal to 16.33. Then, we have to square 16.33, and that is equal to 266.6689 or 267. Therefore, Mario needs a sample size of 267. Okay. So note, so in determining sample size, we always round up the resulting value to the next whole number. So these are the rules. So when the calculated sample size is not a whole number, it should be rounded up to the next higher whole number. Okay, then rounding up a sample size calculation for conservativeness ensures that your sample size will always be the representative of the population. Example, if the sample size calculation determined that 2006.083 data points were necessary to represent the population, then the sample size to be taken must be 2007. Even though the decimal digit after the decimal point is not equal or greater than 5. So we always add 1 to the number. Okay, and then express that into whole number. Next, suppose the calculated sample size is 409.14. What would be the sample size? In this case, the sample size must be 410, even if the next digit after the decimal point is not equal or greater than 5. So that is the process on how to round up the sample size. So I hope I help you, this video help you in doing your activity. So thank you for listening and watching.